So today we're going to look at excess reactants, and of course excess reactants goes with our stoichiometry problems and builds off of limiting reactants. So let's say we have the following equation. 2 rubidium, or 2Rb, 3P, which is rubidium phosphide, plus calcium sulfate, yields calcium phosphide and rubidium sulfate, okay, as you see right here. So first off, when we are working with excess reactant, remember, excess is what we have left over in the reaction. So whenever we're doing a reaction, one is limiting usually and one is in excess. So limiting gets used up first and the excess is what's left over after it reacts with our limiting reactant. So first off, with this example, it gives us 25 grams of each reactant are mixed. So I'm going to put 25 grams under each. So anytime we are asked to find the excess reactant, the first thing we have to do is find the limiting reactant, because the limiting reactant is basically what controls how much of everything will either be used or produced. So when we were solving for limiting reactant, we were trying to find out how much can be produced from the limiting reactant because it's used up so quickly. So what we're going to do with excess reactant is we are going to convert from the limiting reactant to the excess reactant to see how much of the excess reactant will actually be used, and then we're going to take how much was used and subtract it from the original amount. So let's get started. Anytime we're finding the excess reactant, the first thing you do is find the limiting reactant. So we are going to take both of these compounds and we are going to convert it to one of the products. For me, I am going to convert it to Ca3P2. So I'm going to convert this to grams, and then that way I can see which one's limiting based off of which one runs out first. So I have 25 grams of rubidium phosphide. So the first thing I'm going to have to do is I'm going to have to convert this to moles of rubidium phosphide. And so I'm going to add up this formula mass on the periodic table. And when I do, I get 287.38 grams of Rb3P. Okay, so this will cancel out, and now I want to go to my product and see how much of Ca3P2, or calcium phosphide, it can make. So I'm just going to pull the mole value, or the coefficients. So I have 1 mole of calcium phosphide for every 2 moles of rubidium phosphide. Okay, so moles of rubidium phosphide cancel out. And lastly, I'm going to go back to grams, but now of calcium phosphide. And so I want to get rid of moles of calcium phosphide. And so I'm going to add this up from the periodic table, and I get 182.18. So moles cancel out. Right, and so with 25 grams of rubidium phosphide, I can make 7.29 grams of calcium phosphide. Okay, and so that's one reactant, or that's one amount that can be made from this reactant. But there's 2 reactants, so let's do a second one. 25 grams of calcium sulfate, sulfite. And we are going to change it to 1 mole of calcium sulfite. Okay, so we add up calcium sulfite on the periodic table, and we get 120.11. Okay, so grams are going to cancel out. And then we are going to use our mole ratio to go from what we started with, which is calcium sulfite, to our desired substituent, which is calcium phosphide. So I have 1 mole of calcium phosphide, and then I have 3 moles of calcium sulfite. Moles of calcium sulfite are going to cancel out. And then now we are going to go to grams of calcium phosphide. Great thing is we've already calculated this mass. And we're going to cancel out moles of calcium phosphide. And when we do that and plug it into our calculator, we get 12.6 grams of Ca3P2. Okay, so in order to use our initial values they gave us. So to use up all 25 grams that we put into a beaker of calcium sulfite, I can form 12.6 grams of calcium phosphide. To use all 25 grams of rubidium phosphide, I can only form 7.29 grams. Okay, so basically, which one produces less means that it has run out first. So since I only can produce 7.29 calcium phosphide or grams of calcium phosphide here, that means that rubidium phosphide is my limiting reactant. So if that's my limiting reactant, or LR, that means that this reactant, so calcium sulfite, is my excess reactant. Okay, so this is going to be our focus. We want to know how much we are going to use up of this initial amount to completely react with our limiting reactant. Okay, and so like I've mentioned to you guys before, limiting reactant is the start of all of our problems after this, because it's what is used up first or runs out first. So in order to find the amount of excess reactant that we have left over, we are going to take the limiting reactant's original amount. Always use original numbers. Don't use numbers that you have calculated. So 25 grams of rubidium phosphide. And I am going to convert it to my excess reactant. And so I'm just pulling numbers from the top to help me. So if I'm getting rid of rubidium phosphide in grams, I'm going to use this 287.38 grams of RB3P for every 1 mole. And then, of course, I want to go from one reactant, so my 2 moles of RB3P, to my excess reactant, which has 3 moles of calcium sulfide. And then I can pull this mass from what I've already calculated, or recalculate calcium sulfite's mass, which is going to be 120.11 grams for every 1 mole. Okay. And so when I plug this into my calculator, I'm left with 15.7 grams of calcium sulfite. All right, what you plug into this equation, this is what we use/need to completely react with all of my limiting reactant. But I can go back to the original problem or my original work, and I see that they gave me, or this is what I have, 25 grams. So it's kind of like going to the store. I have to pay $15.7 to pay for some clothes or maybe some food. Well, I have $25, so I'm going to hand $25 to the cashier, and they are going to take 15.7 away from 25, and it's going to leave me with $9.30, or 9.30 grams of calcium sulfide left over. And that's how you find excess reactant.